Hi, everyone. Welcome to the Drone Nerds Tech Talk with Quantum Systems on the Trinity F90 Plus. Thanks for joining us. I'm Michelle McMillan, Marketing Director at Drone Nerds. I have Sam Sacalis here. He's Enterprise Lead at Drone Nerds, and he's also a qualified quantum specialist. And we're happy to have Martin Herkommer with us from Quantum Systems. He's a Senior Manager of Global Commercial Sales there. And we are recording this tech talk and we'll be sending it out to everyone who registered. We have a lot of great info to go over today, so I'm going to go ahead and turn it over to Sam.
Thanks, Michelle. Hey, Martin, how are you?
Yeah, well, hi, Sam. Nice to talk to you. Hello, guys. Welcome, ladies and gentlemen, and I welcome you everybody at the headquarters in Germany today. And it's my pleasure to do this presentation with you today, hosted by our partner, Drone Nerds, and I'm here with Sam. Hi, Sam, sales manager at Drone Nerds in Miami, Florida, and together we will try to entertain you a bit for the next 60 minutes with some facts about the best eVTOL UAV in the market, the Trinity F90 Plus. How are you doing, Sam?
Great, Martin. Great, man. I'm excited. I'm excited to learn a little bit more about this product. Excited to see some of the newer items that we're going to be talking about today, and you know, after reviewing it with you, it's some pretty cool stuff that we're going to cover today on what this VTOL solution can do.
Cool. And yeah, Sam, I think you will read the chat while I'm talking, and whenever there are important questions, I think Sam will interrupt my talk, and I will try to answer those questions. If they are not too many, please stop me whenever there are some interesting questions are coming up, Sam.
Absolutely. So guys, just feel free to pop any questions in there. Obviously, if Martin answers them as we're going, I won't address them. But you know, if we keep seeing a run-on of the same question happening, we'll pause and we'll address it on the spot and keep going from there.
Yes, and I'm sure later Michelle will talk again. And thanks, Michelle, for the nice words in the beginning. And I'm super glad to do this early, late evening, but early afternoon session for you in the US.
We're excited to have you.
Yeah, I will now try to share my screen. Let me do that. Screen number 2. So now everybody should be able to see the screen. Is that correct? Sam, can you see it?
Looks good.
That's good. Okay, so well, first of all, I would like to go a little bit over the agenda for today, the content. I would like to talk about the eVTOL UAVs and the Trinity F90 and why Quantum System did innovate this aircraft during the last couple of years. Thereafter, we will focus on the Trinity F90 Plus payload compartments. Here, I can already tell you something new is coming up, and please stay tuned. We have the greatest payload ever development in the last couple of months, and stay tuned to learn more about this interesting payload. Then I will show you a bit of a kind of a use case on Trinity PPK accuracy without ground control points. And then I would like to introduce the coverage plan. The replacement coverage plan, the RCP, is something new. We just introduced a couple of weeks ago, and this is kind of an extended warranty where you can learn how you can get your aircraft easily replaced, even if you damage your aircraft by a manual, by a pilot mistake or pilot error. Then I'd like to show you a nice proof of concept from a big project in Paraguay. Huge area being flown with the Trinity F90 Plus, 50 by 50 square, 50 by 50 kilometers, huge area. And I can show you how you can plan such large area and start to be competition to manned aviation. Then some practical plannings with the Qbase 3D, our software for flight planning. And I'd like to take you to Europe with that example, to Spain, to Gibraltar, and show you a bit of a 3D flight planning in a very complex terrain situation. Well, finally, some F90 key features I would like to talk you through, and then we will start a question and answer session. And I'm looking forward to hear all your questions you're coming up with during this hour of presentation. Well, unmanned aircraft systems. Typical multicopter and fixed wing systems have advantages and disadvantages. And while multicopters, like the one on the left side, are easy to use, they have very limited endurance. While fixed wing aircraft can be used to survey large areas, but they are difficult and also kind of dangerous to handle. So there's an example for a fixed wing aircraft on the right side, and you can easily see the catapult, and I can tell you shit can happen with these kind of catapults, and it can be really dangerous. So eVTOL, so-called electric vertical takeoff and landing UAVs, are an innovative aircraft design that combines the advantages of the helicopters and of the airplanes, like our Trinity F90 Plus. And today I would like to talk a few minutes about our Trinity F90 Plus, a kind of eVTOL solution with the longest flight time in its class. So we call it Trinity F90 Plus, and the F stands for flight time. It means flight time, and the plus 90 stands for more than 90 minutes. So from the beginning, you need to understand that this aircraft is doing a real 90-minute flight. And that means it's doing a 90-minute flight with the full payload, with normal weather conditions, with a on a windy day. And it's not somehow what kind of 90 minutes, it's real 90 minutes or even more than 90 minutes. The aircraft has been designed to fly 120 minutes, but we decided to call it an F90 Plus because we are pretty sure that we can do the 90 minutes in under any circumstances. Other key features of the Trinity are PPK. So the PPK is included to the bundle, to the main, to the basic package, if you wish. And we have optional ADS-B out, a kind of a transponder, which makes your Trinity visible for all other airspace users, like pilots of manned aviation. We did include the strobe lights to the basic package and various plug-and-play, ready-to-go payload compartments. Let's have a closer look at the available payload compartments, and all of them are ready to fly. They are just plug and play, and most of them you can buy right now. There are two new payload compartments, which I will mention later. But let's start with the ones which are available today. We do have the Sony UMC camera with 21 megapixel on the left side. Here we have the Sony UMC, which is a great tool for mapping, mining, inspection, monitoring, and industrial applications. Then the slightly more expensive payload, the Sony RX1R2, which is similar to the Sony UMC, but with a much higher resolution. That means you can fly at the double altitude if allowed, and you will have the same ground sampling distance. This is a great tool if you want to fly in very complex terrain. Like our customer in India, they are operating it in the Himalaya, for example, near the Ganges River. And for them, it's a nice opportunity to fly in 200-meter elevation altitude instead of 100-meter altitude with the same pixel size, with the same ground sampling distance. This gives you more safety. And of course, you can also use this sensor to cover larger areas with still having a 5 centimeter, 3 centimeter pixel size. Then the first camera, which is new, but it will be available approximately in April, is the Sony UMC plus TX thermal. This is a FLIR camera, which is coming out in the beginning of next year. And then we have a bunch of MicaSense cameras like the Red Edge MX, the Sony camera bundled with the Red Edge MX. We do have the MicaSense Red Edge MX dual camera. This is two MicaSense MX cameras together with much more bands, which is a great tool for any scientific application, but also for precision farming. And we do have the MicaSense Ultim camera, which is actually a kind of a Red Edge camera with higher resolution, with more pixels, and an additional thermal band. And then last not least, we have the Cube 240, and I will introduce this new payload in a few minutes. Let's first have a look at the thermal camera. This is the TX FLIR Tau 2 camera. At 100 meters above ground, we can do 2.2 centimeter in RGB, and still kind of a 9 centimeter resolution in the thermal band at 100 meters above ground. This camera is available in April next year, and we are looking forward to bring this camera out to the market. So now the new payload for 21, which will be an amazing payload, it's an outstanding payload, is the Geomatics grade LiDAR sensor, fully integrated in a Trinity payload compartment for a 1-hour flight time. At 100 meters above ground, this LiDAR solution will cover at least 2,000 acres. You got it right, 2,000 acres in 1 hour at 100 meters above ground. And this is a class 1 eye-safe laser at 905 nanometers. We can fly in altitude of maximum 140 meters above ground. And our recommended altitude is 100 meters above ground. The scanner field of view is 70 degrees, and delivery will start in February 2021. Bundled with software, so it's a plug and play system. You can just buy it, operate it, and data processing is super easy, and the data accuracy is outstanding. Let's have a look at the data and the accuracy.
Just real quick before we move on, yeah, I just want to make sure, so these systems, as they're getting delivered, and they have, the little attachment bays that go into the actual Trinity itself, they're being integrated into the bay and then plugged into the Trinity system itself, correct?
Correct. Every camera will come with its own little bay, with its own payload compartment, and it's a fast locking mechanism. You just flip the payload compartment into the Trinity, and the Trinity will automatically know which payload is connected. And then in the flight planning software, you will select the right payload, and then you are guided through the flight planning. That means you just draw on a kind of an area, and it's automatically calculating your runs and distances and altitudes and densities and so on.
Perfect.
Correct. And maybe one more thing to mention is it's a single button solution, the LiDAR. So it's nothing you have to configure with an iPhone or with a tablet or with an iPad. You just plug it in. It's powered by the aircraft itself. And then there's a single button. You press the button, it starts to record the data. You fly the mission, you land, and you stop the recording by pressing the button a second time. And then you just pull out the USB stick with all the data on it. You process it, and then you have a ready-to-go LAS file, nice point cloud.
And it's all 100% PPK.
It's all 100% PPK, correct. Maybe some folks are asking why we call it Cube 240. Cube 240 stands for 240,000 shots per second with 3 echoes or returns per shot. So that's what I mean with this equation here. It's a Cube 240, 230 with an exponent 3 echoes, and that's why we call it Cube 240. I think that's a cool name, and it stands for a high accuracy and a high precision. If you look at this slide, and it's really true, the precision is 1.8 to 2.5 centimeters, and the accuracy is better than 3 centimeters, the absolute accuracy. And we can incorporate ground control points, and can even use the ground control points in the software to optimize the alignment, and we get a point density of more than 50 points per second at 100 meters above ground, so up to 100 points per second, depending on how many first, second, and third pulses we can retrieve. But this is an amazing system, and let me zoom in a little bit to this point cloud, and you can see we can easily see and measure all the cables, the structure of the tower, and the specs with 100 points per square meter and up to 3 echoes. per shot are defining a new class of lightweighted LiDAR sensor on the market, and there's absolutely nothing to which can compare to this kind of sensor, which you can fly in February with the Trinity F90 Plus.
And another question we're having is, is the time of flight, does it have an effect on the actual Q240 itself, whether you're flying daytime, nighttime, early morning, mid-afternoon, anything like that?
That's a good question. That's the problem when you're using daylight cameras. When you are flying a Sony camera, you can operate it in daylight time, and multispectral data is even more sensitive to sunlight angles. So you can only fly, let's say, from 11 o'clock to 2 o'clock, because the multispectral cameras don't like the flat sun angles. But the LiDAR will work at any time. It will work early morning, at night time, at any time. It's not relying on sunlight, on reflectance. It's shooting with the own light impulse on the ground. It's an active sensor, and it's getting the light back. And so you get comparable data at any time. It's just about the colorization of the point cloud. If you want to colorize the point cloud later, you should fly a second flight with the Sony camera to create an order mosaic, and use this order mosaic, which is on the same accuracy level, to colorize the point cloud. But if you don't need colorized point clouds, you can fly at any time.
And are you also collecting any RGB data with the Cube 240s?
Not the same flight, but the idea is to do 2 flights. One flight with the LiDAR, like 1 hour with the LiDAR, and you need a second hour with the RGB camera, and then both data sets are co-registered with the same base station data, so it's the same PPK. So you will be able to colorize the point cloud, and that's anyway a better solution than flying the RGB camera at the same time, because an RGB camera will never have the right interval to shoot the data with the right overlap. So when we are flying at 100 meters above ground with 20 meters per second, it will not be very easy to get the right coverage with an RGB camera like the LiDAR data, because the LiDAR data is looking at a much flatter angle than the RGB camera. So we anyway recommend to fly to 2 flights, one for the LiDAR and a second flight with a different setting, optimized for the photogrammetry with the RGB camera.
And what's the recommended speed to be flying the Trinities in? What's the airspeed?
You are not much flexible. Anyway, the Trinity is, the user can set up the Trinity anything between 17 meters per hour and 20 meters per hour. But this is for the normal camera systems. As the LiDAR is slightly heavier, we do limit the Trinity to a fixed speed of 20 meters per second. So once you are deciding to fly the LiDAR, you are anyway set to a fixed flight speed of 20 meters per second.
Perfect.
Okay, then ready to zoom in a little bit more. Please watch the power lines and the tower. And when I zoom in now, we can see that we can even survey the position of the small isolators with an accuracy of better than 3 centimeters. Of course, as I mentioned right now, we can do a second flight with the Sony camera. We create the order mosaic, and then we use this order mosaic to colorize this point cloud and create a colorized LiDAR point cloud. So if there are not any more questions about the LiDAR, if not, I will move on to the photogrammetry solution.
Yeah, so one more question, and that's going to be the manufacturer of the Cube 240. I think you mentioned earlier it's Livix.
Well, what I can say is it's based on a LiWorks sensor, and it's a high-grade IMU built in, but I would not like to talk right now about what exactly is in there, because we will release it in February. And I will not mention a price today, but Drone Nerds will definitely provide a good price to all users. And I can already tell you it's cheaper than you think, and it's much cheaper than any other solution on the market for this kind of geometric grade LiDAR. So stay tuned, get some quotes from Drone Nerds, and you will be surprised about the price point, the price tag. And if you place early orders, maybe pre-orders, we can guarantee a delivery in February or latest in March, depending on how many orders there are already in the queue.
Perfect.
So let's have a look at the accuracy we can achieve with the RX1 camera and our included PPK system. So the PPK system is included to any Trinity, and it comes with the airborne PPK, and it comes with the ground-based base station, the iBase. And this is part of a normal bundle, and you don't pay extra money for the PPK system. And maybe to mention, the PPK works not only for the RX1 and not only for the Sony UMC, it works with all kinds of sensors we are using. And this is something which is unique on the market. Our PPK works with the Altum camera, it works with the MX camera, Red Edge MX camera, and with the dual payload, with the thermal camera. All cameras are compatible with our own PPK solution. So let's have a look at the accuracy we can achieve at an altitude of 100 meters without any control points. This example is showing a 30-hectare area. It's kind of a test site, which has been surveyed in 20 minutes at around 110 meters above ground level. 745 images with 75 by 75% overlap. So 75% in the flight direction and 75% lateral overlap. And the ground sampling distance is 1.35 centimeters per pixel. The accuracy of the outer orientation was calculated by Agisoft Metashape with an accuracy of better than 2 centimeters. Let me just mention, we work with Metashape, Agisoft, we work with Pix4D, we do work with Propeller, we do work with Triple Business Center. So we are not focusing on one post-processing software. So all kind of third-party software is working seamless with the Trinity F90 Plus data. It's just here, I was doing this test with the Agisoft Metashape, and here we calculated the accuracy of the outer orientation, the camera position in the air with an accuracy of 2 centimeters. Then when we look at 11 well-distributed checkpoints, so these checkpoints are measured with RTK GPS, we can verify that the absolute accuracy is better than 2 centimeters in X and Y, and much better than 3 centimeters in Z. The elevation accuracy level can be expected to be 3 times the pixel size of the imagery, and we do remember the pixel size was around 1.35 centimeter, and this should allow approximately 2.7 centimeter accuracy. Let's have a look at the individual accuracies of the 11 checkpoints. And in the last line, we can read the mean accuracy for this flight. 2 centimeter in X direction, 1.3 centimeter in Y, and 2.8 centimeter in Z. Without using the ground control points to improve the accuracy, the ground control points are just kind of checkpoints. So we are definitely talking about a survey-grade accuracy, and the Trinity F90 Plus is the right tool for large-scale survey-grade mapping projects. And as this data is more accurate than 3 centimeter, and you remember that the precision of the LiDAR is also better and around 3 centimeter, these two data sets, the auto mosaic and the point cloud, can be merged together on a point-to-point level. So every single point of the point cloud will get the right color from the auto mosaic. So it's the right tool for survey-grade mapping projects, and the first choice, I would say, for any geospatial surveyor.
And when it comes down to the geotagging, is that something that's done through the software itself, or is that a manual task?
No, it's done through the software of Quantum Systems. So Quantum Systems Qbase 3D is used for the flight planning. Then we do execute the flight, and we monitor the flight with the Qbase 3D. And then right after landing, we transfer the flylog file and the images from the camera to the PC or laptop. And we use Qbase 3D to do the post-processing and geotagging, and then we can hand over the data to Agisoft, Pix4D Mapper, Pix4D Survey, Propeller, Trimble Business Center, whatever. It's any software will work with this data. Some of them, they will need an additional file like a CSV file or an internal file, which we can produce. So whenever you are geotagging with our software, you can activate checkboxes to say, well, I want to export some Propeller information file or a Trimble Business Center information file or a Pix4D geotagging. So the customers are quite free to decide which software they want to use. And of course, the accuracy is always the same. The accuracy is written to the images by the geotagging or to the geotagging file. And then from there on, it should result in the same accuracy, disregarding which software you're using for photogrammetry and for post-processing. It's physical principles. So if there are no more questions about photogrammetry, I would like to talk a little bit about a replacement coverage plan, which we call RCP. Did you read any more questions, Sam?
No, actually, it's going to be going into this discussion itself. You know, wanting to talk about different repair centers that are available here in the U.S. because obviously these are not going back to Germany or anything like that.
Yeah.
So you know, when you're talking about the replacement coverage plans, if you can touch on, you know, who the authorized repair center is. I mean, obviously we are one of them.
Yes.
But yeah, if you can just touch on that as well,
okay.
That's one of the questions.
Okay, so the replacement coverage plan is an additional warranty extension, and a non-warranty drone replacement is made available in case of, for example, a self-induced drone damage or even a manufacturing fault after the 12-month warranty period. The replacement coverage plan is covering, for example, flight planning mistakes with the RCP. It will not be covered without an RCP. It's covering mishandling, change of environmental conditions, like you are taking off in a nice sunny day, and while you are flying the mission, the drone is far away. A kind of a storm is damaging the drone because you couldn't see that because you are probably flying in a huge distance, things like that, or transportation damage or manufacturing fault after the 12-month period of warranty. And this RCP can be booked for the first year, the second, and the third year, and it will replace all the flying parts of the drone. So it will not replace, for example, the expensive LiDAR. It will not replace the cameras, but it will replace all the flying parts like the main body, elevator, rear fuselage, wings, batteries, payload compartment, the telemetry modem, and so on. The price point is quite interesting. It's the first year is 3,490 euro. So roughly talking about I would say $3,600, $3,800 roundabout. And then every subsequent purchase will be $3,990, so $4,500 approximately. But, and now if you do not use the RCP, for example, you book the RCP for the first year or the second year and you don't use it because you are not damaging your drone, the next year will be credited with a 50% discount. So it gets cheaper and cheaper. So if you don't call for the RCP, you will profit the next year by getting a 50% discount on this RCP. And this RCP, we see it as on the one hand side, it's a kind of an extended warranty for the second year, but it's much more than that. It's kind of an Apple care protection plan. So you damage your drone and we will not ask questions why it is damaged. And if you did something wrong, you will just get a new one. And this is a very interesting offer, especially for, I would say, for institutes, universities, and so on, with daily or weekly changing pilots. So if a university buys, for example, a drone, and they invest, let's say, $20,000 of money, and they give it to students to fly it, they would like to make sure that their investment is somehow protected for the next 3 years, because the money they used is a budget for a drone for the next 3 years. So they should be pretty happy about having a way to kind of insure their investment by using this RCP. And this RCP is different to a normal insurance, because in normal insurance, after the first crash, they will not give you an insurance anymore. Here you can buy the RCP for 1 replacement. You can buy the RCP for 2 replacement. It's just a question of money. And if you don't crash, or you do just a minor damage, we would recommend you pay for the minor damage and don't call for the RCP. And then you get the big discount for the next year. So this gives you a bit of a flexibility in planning your investments and securing the investment for the next couple of years.
So just a question going back to the Trinity system itself. Is this VTOL solution, does it have anything that it gets affected by electromagnetic interference? Does that play a factor at all?
No, it's no factor at all. We do use a magnetic compass, but only on the ground before takeoff. That means the magnetic sensor is used for kind of calibration of the heading before takeoff. There will be an indication if something is going wrong. So, for example, if you place your Trinity on a metal part or on a car, it will refuse to take off. Like it will not work. It will show a magnetic error. But once there is no dysfunction on the ground before takeoff, and you can go through the checklist, and it's giving you the green light for takeoff, you're fine. Once it is airborne, the magnetic sensor is switched off, and that's why we can fly quite close to power lines. So you remember the project with the power lines. You can fly like a 10 meter, 20 meter distance to a power line. This will not harm the system at all, because it's not affected by any magnetic interference. The only interference I see at the moment for the Trinity is super high wind speeds, and this is a matter of physics. We are flying at 17 meters per second speed, and if the wind speed, which comes from the front, is same like 17 meters per second, then the Trinity will stand still and will not fly anymore, because in the aviation we always talk about airspeed, and if the airspeed, if the wind is 17 meters per second from the front, it would even lift off automatically from the ground. So that's why we limit the wind speed to 12 meters per second. It's not just because we are not cool enough to fly at higher wind speeds. 12 meters per second wind speed means we have a 5 meters per second tolerance to our own airspeed, and this is limiting. This is a limiting factor. And even flying with a lateral wind direction, that works best. So then you're flying with a grab angle, and it can fly at 12 meters per second wind speed. But when you approach for landing, and the wind is rising, the wind speed is going up to, let's say, 17 or 18 meters per second. At 18 meters per second wind speed, the UAV will fly backwards. And this is a mission critical fact. And that's why we try to protect ourselves and the unit by having automatic fail-safe mechanisms. So that means if we detect wind speed more than 12 meters per second somewhere in the air during the mission, it will come home and land, and the user can't override that. So we make sure that the system itself is taking decisions, because the pilot is not able to take decisions because he has no idea about the wind speed in the air.
Right.
And this is a real factor, and that's what I have seen in Florida too. I've been flying many times in the Palm Bay area, and I experienced that the wind speed on the ground is maybe 5 meters per second, and every 50 meters you go higher, you double the wind speed, because there's an ocean on the right side, on the left side of Florida, or east and west, and change of weather conditions happened very quickly there. So the wind speed is rising much faster than you would expect. And then it's a good feature that the Trinity is making its own safety decisions and trying to come home and land automatically on the takeoff location.
And is there at any point where the user can actually take over the Trinity itself and bring it back home, or press something to force it to land or anything like that?
Anytime. So you have two options. There's the remote control in your hand. Whenever necessary, you can interact by touching the control sticks. This will give you a kind of an assisted flying control. So you can make a left turn and a right turn with limited bank angles. So you can't crash it. You can just the full stick to the right will make a circle to the right, and a full stick to the left will make a full circle to the left. And the same with the stick up and down. It will climb and it will descend, but it will never override a specific climb or descent angle. At any time, the user can do that. And if you release the sticks after 3 seconds, it will go back to mission. So you can use this to avoid air traffic, for example, to avoid any collision in the air with another drone or with an eagle or with an aircraft.
Right.
And more than this, you have specific maneuvers you can start in the air. So for example, there is a maneuver called anti-eagle maneuver. This is something we developed for our folks in Australia, because they have these big kite eagles and wedge eagles. And they had several accidents with eagles taking the Trinity out of the sky. So we designed an anti-eagle maneuver, which means to press an anti-eagle maneuver button on the remote control or on the laptop with the higher radio control range. And then the Trinity will climb very, very steep up and will climb above the eagle. And the eagle or any kind of these raptor birds, they are kind of lazy guys, and they don't want to climb and spend energy to climb above the Trinity again. So they will lose interest in the UAV, because you put energy into the climbing. And after a while, you can release, and the Trinity will go back to the mission altitude and continue with the mapping. We will not lose any single photo. The Trinity remembers where you stopped, and it will go back and approach the same run, and will continue the mapping after you did this anti-eagle maneuver. This works perfect. We have very good results from Australia, from India, from all over the place where these birds are active. We never seen a problem in Germany. Probably our eagles are too small, and they are not attacking the Trinity at all. But I'm sure in many states in the US, the eagle or kind of eagle problem will exist, and therefore this feature is not a gimmick. It's a really important feature which can save your investment. Then of course you can press coming home at any time, so the mission will be aboard and the unit will come home to the descent location. It will make the descent circle at the predefined position and go for landing at the takeoff position. And then there are some other two maneuvers which we highly normally not recommend to use. One is the land immediately. That means wherever the Trinity is, even in a 5 kilometer distance, if you press it, it will stop in the air and it will go down vertically and land. Sure, this can happen in a alligator wetland in Florida. So you will not be able to reach the position of your Trinity to get it back. Or there's another feature called abort mission, which will cause a spiral dive and destroy of the aircraft. This is more or less for scenarios when you, for example, operate a Trinity in an area where search and rescue forces are active, like you have a hurricane, after a hurricane, and you are operating in the same area where the federals are flying with helicopters, and the police is flying helicopters, and the ambulances and so on. And someone tells you, please get out of the sky now, then you press the button and your Trinity will be destroyed on the ground, but it's much better than a collision with a helicopter, for example. That's why this is a law in Germany to have this feature, but there are 2 or 3 questions. Are you really sure to do that? Yes, I'm sure. Are you really sure to destroy a system? Yes, and then you press it, and then it's done. So and then, well, you will have to buy a new one which is not so good for your clients, but good for drone owners probably.
So I do have some more questions for you, as it relates to going over the warranty itself, right? So obviously the system, you're not able to operate this. Are you able to operate this in wind? I'm sorry, in rain or snow or anything like that? Any kind of a wet condition?
You should technically, when it starts to rain, you should abort the mission and bring it back for landing. It will not fall out of the sky, because we have a new safety feature, which is making somehow the pitot tube for the speed measuring redundant. So yes, we need the pitot tube for measuring the airspeed, but if it is blocked by rain, it will go to a fail-safe and it will go to a fixed throttle setting, and it will fly at a slightly overspeed to prevent a stall. Stalling is if you fly too slow, an aircraft will fall out of the sky, and this cannot happen because we will detect when the pitot tube is failing, and we will then go to a safe speed setting. But actually, we recommend, and what we say and what we write in the manual is, do not fly in rain. It will also not make much sense either with the LiDAR or with the photogrammetry to fly in rain, because the data quality is poor and you can't use the data afterwards. And more important than that, the cameras are not waterproof at all. So if you fly in rain and the water gets into the payload compartment, your expensive Sony RX1 camera is probably damaged. The same for not the LiDAR. The LiDAR is waterproof, but it doesn't make much sense to fly in the rain. We will have a new pitot tube in the next year, so expect something to come in the next month, a new pitot tube, which will be 100% waterproof. Same pitot tube we are using with the Vector and Scorpion, with our military grade systems, but still, it doesn't make sense to fly in rain, and there's so much other parts of the Trinity and the electronics which are not really waterproof. So we recommend to stop flying when it's starting to drizzle, and get it home and land it, wait for a while, and then fly again. I think in Florida it's quite, you can easily predict the weather, and whenever bad weather arrives, it takes a while, and then it's back sunny, and you just have a break and give it some time to
Wait 5 minutes and then back in the air.
Yeah, same like Ireland. I experienced it here in Europe, in Ireland. If you don't like the weather, wait 5 minutes. Yeah, but
so
yeah.
Another question we're getting, and it pertains to the actual warranty, the extended warranty program that you're offering. Is the replacement itself, the shipment, right, the transport of the unit to Quantum, is that covered in the warranty itself?
If I remember correctly, and we sent you the details, I think we cover the shipping from Quantum to the reseller, and you have to cover the shipping from reseller to Germany.
Okay.
And probably the customer has to pay for the shipping to the reseller. So your clients would need to pay for the local shipment to Drone Nerds, and you will pay for the shipping to Germany of the damaged unit, and we will ship you one unit for free to the US.
Okay, so that's something, yeah, they deal that with their dealer directly. The next question is
always through the dealers. We would never interact with your customers directly, and I think that's also important, that the reseller is in charge of handling the customer and doing all these RCP processes. And
is there a lead time on the replacement part? Is there guaranteed 1 week, 2 weeks?
Well, this depends really on the reseller. So from our point of view, we have a stock right now. So we have 80 units in stock. It sometimes depends on the configuration, but we have plenty of units in stock, so we could theoretically ship in 3 day or 2 day prior notice.
Okay.
And but the recommended way to do that, and that's what we do in most places, is the reseller is stocking units, sales units. A customer is experiencing a damage and wants to call for the RCP. The customer will send the flying parts in the box. He will keep the non-flying parts at his location, and he will send the flying parts in his box to DroneNerds. DroneNerds will send these flying parts in the box to Germany, but in the meantime, the same day or even before you get the parts, you will ship out a new box with only flying parts. You take one of your sales units, you will remove the non-flying parts, you ship out the flying parts. So you can technically, theoretically, you can bring a unit to your customer's location in 24 hours or 48 hours. And we will replace so then you are sitting on some non-flying parts in your stock, new parts, and we will ship you a new box with new flying parts, and you just put your non-flying parts in, and you have a new sales unit ready to go. So nobody is losing time. Everybody has a new system, and for the client, it means he can expect some kind of replacement unit in less than 2 days. That's the idea behind it. And I think many people are working on a time-critical survey. They are surveying on a contract basis, and they need to fly so and so many acres per day, or kilometers per day, or miles per day. And for them, it would be a nightmare to stop for 1 week or 2 weeks or 3 weeks in a project if they have to deliver deliverables to the end customer, to the contractor.
Another thing I want to ask is, when it comes down to warranty replacement, right? So we're talking about, let's say the customer has a flyaway, right? Where the unit has completely disappeared, it's lost in the woods. I'm getting a lot of people that are in mountainous regions, so they might not be able to recover the Trinity system itself. What do we do in that situation?
That really depends. There are ways to get kind of evidence for what happened. For example, we have a log file on the laptop, so the laptop is also logging data. So if the laptop, the Qbase log file is provided, we can prove that the system did fly away or not by watching the last log file, and therefore we probably will we will replace the flying parts if it disappeared somewhere in the woods or in the ocean or somewhere. It's not always 100% necessary to bring back the parts, but we have methods to prove what happened, because there are so many black box files going on. There are black box files in the Trinity, so if we get the damaged Trinity, we can read out all the parameters and can find out what happened and why it happened, which will not make much difference for the RCP, because we will even replace if it's our mistake. But we can definitely prove whether someone is saying, "Oh, my Trinity disappeared," and in fact it's sitting in the garage, or but we have ways to prove that by reading out some log files from the Qbase. We can't read them out by remote, so we are not talking to the system, but we will ask the client to send us the log files to prove the story. It's always about it's also about trust, but sometimes it's about proving the story, because you can imagine we have experienced a lot of stories in the last year.
And then that also plays back to the transponder itself, the files like you were just mentioning with Qbase. I mean, there's so many different ways that you're going to be able to tell and see exactly what happened in the situation. So I know Quantum is very fair when it comes down to assessing these situations.
Yeah, and we are quite fair also in terms of replacement. So I would say in the last 3 years, I'm now working with Quantum, or 3.5 years. Most times when it was like a 50-50 about was it a manufacturer fault or was it a pilot fault, normally we decide to replace and keep the customer happy. But we also experience some stories which have been so far away from reality, and where we have a bulletproof file saying that the unit was taken off like 2 meters next to a tree, and it landed in the tree on arrival. And there we can't replace it, because nobody should take off like 5 meters or 2 meters next to a tree.
Absolutely.
One thing I just want to say, if I can, I see a couple of people have their hands raised. And if you have a question, just ask it in the Q&A area, please.
Yeah, we actually don't see the hand. I can't see the hand raise thing, but yeah, like Michelle was saying, if you have questions, just type them. just for everybody listening, I'm seeing the beyond visual line of sight questions. I'm not ignoring them. I want to actually address them in the next section that Martin's going to go into, which is actually extremely interesting, and it should help as well.
Okay, so let's now move on a little bit about the proof of concept for a large surveying project in Paraguay. And when I show you the next slide, you will say, wow, 50 kilometer by 50 kilometer. When I saw this first time and the customer sent me the KML file, I said, come on, guys, are you kidding? Please use a Piper, Cessna, helicopter, whatever. But it's definitely no job for a DJI or for a Trinity or for any kind of UAV.
Mm-hmm.
But after doing some maths and well, what I first did, I separated the area in 16 tiles. Each tile is 12 by 12 kilometer roughly. And then when we look at this, it becomes much easier. We import this to the Qbase, and I did create a first flight plan for a small part of one of these 16 tiles. And as we can see here, the flight time, the total flight time in the lower left corner of my screen is 54 minutes. Yes, we can fly 90 minutes, but this is Paraguay. And for this project, it was very time critical. And we've not been able to provide an unlock code for Paraguay to unlock the 90-minute flight time, which is an export restricted thing. So it will take like 2 months to get this unlock code to Paraguay. So we decided to do all the mathematics and all the calculations based on a 16-minute flight. By the way, for the US, if you buy a drone, you get the unlock code for the 90 minutes the next day. It's any country within the NATO or in Europe, it's in Australia and so on, it's no problem. You get unlock code the next day. But for any other countries, it takes anything between 2 weeks, 2 months, 3 months. It can take 6 months, or you can never get it. It depends where we are trying to sell this kind of equipment. And then it's a kind of a dual use background check from our export regulation office. So this is one flight with a Trinity, 60 minutes. And you can see it's only a little tiny part of the 12 by 12 kilometer tile. So the black line you can see here is the 12 by 12 kilometer. So one of the 16 tiles. So first flight, second flight, third flight, fourth flight. And then I came up with the idea, say, oh, wow. Why not taking off from the center of this big tile of one of the 16 tiles? So in the middle here, in the middle where my mouse is right now, why not taking off from this point and using 3 Trinities at the same time? So one team, 3 Trinities. So you drive to a takeoff location, and from this takeoff location, you spend 1 hour to fly 4 Trinities to cover the 12 by 12 kilometer. And then you stay there and you operate it another time for the next quarter, and another time, so you can do 4 times each 12 by 12 kilometer from one takeoff location. And this is all within the radio link distance. It works well. It's all within the 60-minute flight time and so on. So we have 4 Trinities, and that means per square we need 16 flights. But when using 4 Trinities, it's only a 10 days job. So 1 Trinity would be a 42-day job, but with 4 Trinities, it's a 10-day job. 6 flights with 4 units per day. And 6 flights per day is 6 hours plus 6 hours flight time plus a bit of driving. And this is doable. So our recommendation for that job was, well, buy 4 working units and 2 backup units, just to make sure you get this job done in 10 days. And even if you miss your expectations by not doing the 6 flights per day, only doing 5 flights a day, well, it will take 11 days or maybe 12 days, but it will not take a year or half year or anything, which was my rough estimation in the beginning. When I saw the area, my first impression was, this is a project, this will take a year with a drone, but it will not. It's doable in less than 2 weeks, definitely.
Some questions real quick
Yeah.
before we move on that we're getting about this. So the altitude that you guys were flying at was 700 meters. Is that above, pretty much above sea level, or is that the elevation that the units were climbing up to?
No, this is above ground, but this
Okay.
is legal in this place, because this operation and this project is also done by the MOD. So it's a kind of a military background, this application. And you can see here in the upper part of the image, we are still below a 10 centimeter pixel size. That was the critical setting for the mission. They've been asking for a 10 centimeter auto mosaic, and they asked for a short period of time for capturing the data. And that's why we came up with the Sony RX1, 700 meter above ground, and these 10 days of flying.
And then, another question we keep getting is coming back to the battery times themselves, right? So it's about how much flight time, how many batteries would you say you're needing for a project like that per unit? And then what's, when we're looking at these kind of things, what are we looking at charge time wise?
Okay, let me go back here. You can see this flight on the lower left corner is 1 hour, and we are using 51% of one battery. That means after an hour, we are landing, let's say, with a 60% used battery. So 40% will still be in the battery. That means the charging time for this battery is roughly 1 hour. So it's 1 by 1. If you fly 1 hour, you charge it 1 hour. And you can do that in the car. So there's all Trinities we deliver are coming with a charger, which can be used on a wall plug or with some crocodile clips on the car battery. So you can connect it directly to your car, and you can charge the battery in the field. So while one Trinity is flying, the second battery can charge. So actually, this job would work with 2 batteries only per Trinity.
Right. And
if charging while flying.
One thing I want to keep mentioning, this keeps coming up with all the information and data, and how do you actually know how much you really need? This is where Qbase, the system, the operating system for the entire, it's the mission planner for the Trinity system. This is where all the data, all the information, as you can see, Martin right there, he's got something on the screen. It's mapping everything out. It's got the start, it's got the end point, it's got all the information, all the data, everything that you possibly need to know how much time, the level of accuracy, all the adjustments can be made directly through this system, which is included with the Trinity systems themselves.
Yes, and I will show this in live right now. So if we are a little bit over the time, but we can definitely do some more, like 10 minutes. Can we do, Michelle?
Yeah, that should be fine.
Okay.
People can drop off if they need to, and we'll send the recording no matter what. If you registered, if you're on here, you'll get that.
So let me share with you my screen using Qbase. So when we start Qbase, you can still see it, right?
Yeah, we can see your screen.
I was not sure if it was sharing the window or the full screen. So now we can go to a new mission, and we can create a new mission. Let me first do something very simple as a first example. I do something very simple. Let's go somewhere here in Spain, for example. We go here. Let's go to a flat area first before I show you the more complex stuff. So this is, for example, a kind of agricultural area. And here we wanna do some flights. So what we do is, first of all, we select the right aircraft, like Trinity F90 Plus, and we can select the right payload compartment. So you see there are so many payload compartments. So for example, we are using the Sony UMC camera, which is a kind of a standard, and we set it to a normal flight speed, 17 meters per second, and we apply. And then we can add an element, and we can first of all select the takeoff location. For example, we want to take off from this place here, and then we can draw an area just to make sure everything is easy. So we want to measure, let's say, this kind of area here. Let's say these 2 irrigation fields we want to measure with one flight. So this is 100 meter, resulting in a 2.6 centimeter resolution. If I increase the altitude, the resolution will change. Or I click into the resolution and say, I want to have something like, I want to have a 3 centimeter resolution, and then it will result in 112 meter above ground. We can check the wind speed automatically. So the internet weather stations are providing the wind speed right now on the field, which is for planning not so important because you probably want to fly tomorrow. But before flight, you can log to the internet and you get all the weather forecasts available for this region. So the wind speed is like 1.6 meter per second from southeast to northwest, which would mean I would try to change the leg direction a little bit to the left to fly with a lateral wind, the wind coming from the side like this. And so this is the flight plan, and the full flight time would be 48 minutes. We can see there's a warning here. It's red. It's red on the departure, on the arrival. So we have to rise a little bit to takeoff altitude, and probably also we have to check here the elevation. You can see there is a elevation problem here. So we would need to climb a little bit in the beginning. So it's warning that on the climb there could be a risk on the terrain, and we could avoid that by first climbing a little bit more in the direction and then flying towards the field. The software is full 3D. That means we can check the data in a 3D view, and we do also see that here we are coming back, we are descending, and then we are approaching towards the landing location. So we can of course check the photographs. Now if you check the color here, you can see that we have colors from 3 centimeters ground sampling distance to 4.3 centimeter ground sampling distance. But this is only here a little bit orange. That means all our images will be something between 3 centimeters and 3.5 centimeters. Whenever you change something, like you change the area like this, everything is automatically recalculated. So it's not a big deal doing this kind of flight plans. Let me go back and load a little bit a different area. This is something I would like to show you. Now we are here in the south part of Spain. I mentioned this earlier that I want to show you a kind of flight planning at Gibraltar. And I've been there a while ago doing some flights, and when you check the 3D, you will see that Gibraltar is a really bad terrain for flying. It's super steep. It's super steep. Here are some apartments on the ground here. I was living here in one of these houses while doing the slope erosion assessment work here on these eastern slopes. These are some very steep slopes with bad soil erosion, and we did the flights here. And it's quite risky to fly there because there is steep terrain all over the place. And we also like to map this zone right of the airport. This is the international airport of Gibraltar. And so let me show you how easy it is to do this kind of 3D flight planning here. All you need to do is you add new elements. And let's say we load an area file, and let me try Gibraltar 2 KML, which is a file. Show advanced, and we do the terrain following. Yes, and now we change the leg direction.
And just around. I just want to address this question because it's coming up. When you're putting terrain follow, that means that it's also going, the VTOL solution itself is going to be adjusting to the elevation gain and drop?
It will, give me a second, let me just put in a number here. It will analyze the terrain, And you will see it right now when I go back to the 3D view. Now you can see what I mean with terrain following. It's automatically changing the flight altitude above ground due to the terrain, which we import from the SRTM database from the NASA. So there's a file which is public, which is the so-called SRTM data. This is the space shuttle topographic mission data. And this data is available for most places on Earth. So if we have a look at the data coverage, which is here, you can see all the white areas are covered with SRTM data. This is a free data set, which is pretty accurate. It's accurate enough for all kinds of flight plannings. And this data, these kind of data sets are also used for flying with manned aviation and to avoid terrain conflicts. You can also import files. So if you have an area like an open pit mine where the terrain is changed since the topographic mission, since the space shuttle was measuring this kind of elevation model of the Earth, you just import your terrain file, and then you have a recent digital terrain model for flight planning, which gives you a chance to avoid any terrain conflicts.
And that's something I want to mention right now, the terrain conflict. You know, I'm getting comments that people would be nervous flying this kind of a terrain due to the wind elevation, the changes. Can you address that?
Yeah, well, I was trusting it the last 3 years. I never was disappointed about the accuracy, because we would now, you can see green lines here. Green lines means you are more than 50 meters away from any terrain. If you are less than 50 meters, it will start with a yellow color. So let me try to make this happen. If I lower the altitude again and again, still not. Now you get a yellow color here. That means here you are only 20 meters away from the terrain, and this could, of course, cause a conflict. That's a warning, and it will not let you write the flight plan to your aircraft. It will warn you again and again, and you have to cancel a lot of warnings and say, okay, I know it's dangerous, I will do it anyway. Are you really sure? Yes, I'm sure. But then it's your own decision. It's your absolute your own decision. And I had examples in the last month that people flew into the terrain, and we got the flight plan afterwards, and it was completely red. So the system was telling the user, you will crash your aircraft at this location, and the aircraft crashed exactly on this location. But once your flight plan is 100% green, like it is right now, there's, I would say, zero risk crashing your aircraft. And then you are still monitoring what you are doing. You are the pilot in command, you are observing what's going on, and if you see the aircraft going too close to the terrain, you will probably interact with your control. For example, here, it's always a good idea, if you see it going too close, to make a turn towards the sea. Just fly a left turn or a right turn, depends on which direction you are. But this is the only task for the pilot beside watching what's going on. Being prepared for the worst case and knowing early enough what to do if something goes wrong, make a left turn to the sea or a right turn towards the sea. Right. After the flight, the unit will go back here and descend in this descent circle, and go down and make an approach to this parking area here. So, but not enough only to do one area. We can also load a second area. So we add a new element, we load an area from file, and we now load the second area. I already had a second. Let me remove the second again.
But Qbase will also correct, right? So if you're already planning out a mission and it keeps showing red, will it offer you an alternative? Will it suggest for you to go in an alternate route, direction, change the path a little bit?
Here, for example, now this is an example. Now, good that you ask. Now you can see we have a red line. Can you see the red line here? Here?
Yes.
Because it's trying to fly from the first area to the second area on a direct line, which is not a clever idea because it will go over this little tiny ridge here. So there, now we have to check what we can do. This is the area number 1, and this is the area number 2, and we see the aircraft flying from number 1 to number 2 directly here to this ridge. What I would do, I would just change the order and flip the legs of area number 2. And now you can see the line goes along the coast and there's no red line anymore. Now everything is smooth again. There are no red lines. Here's everything is green, and same here, all green. And we can activate the photo position to see whether we have a good resolution or not. And we can now load a third one. And the third one, let me check the third one at element. And it will directly fly. And now another red line is appearing. We go back to the 2D view, and you see the aircraft tries to fly direct from area number 2 to area number 3. Now, what I do is I go to the transit, I click this point, and I move it to the sea, and let it fly a kind of a deviation course to the sea and back to the third area. So now we have 3 areas in a row. Total flight time is 1 hour and 6 minutes. And we will capture all the data from these 3 areas in one flight. And it will, after the last area, it will come back for landing, make a safe landing, and then we download all the images, and all images will be geotagged in one run. And then we can give the images to a photogrammetry software to process the single areas the same day.
Perfect.
If we check the area, for example, the last area, we go to the plots, you can see how the aircraft is behaving above ground. Same here and same here. So we have the altitude above mean sea level, the altitude above takeoff, the altitude above ground level, and the ground sampling distance. So the ground sampling distance is going something between 1 centimeter and maximum like 3-point-something centimeters over the entire area. But it's never been that easy to do this kind of drone missions. I know that some people think that flying a DJI Phantom, for example, is easy, or a Matrice, or a Mavic. Flying is easy, but the flight planning for a real survey-grade mission is even more complex. That's my personal point of view. I played around with the DJI software on an iPad, on an iPhone, and I got screwed up with the iPad planning a mission with given forward overlap, side overlap, terrain following. This is not that easy. It's just easy to fly, and the system is super forgiving in terms of obstacle avoidance and things like that. But doing a real geographer's work or remote sensing work with this kind of solution is more complicated than with a professional solution like this.
Right. Absolutely.
Last one I want to show here before we go to the questions is a nice corridor mapping project, not far from your location actually, Sam. Last time I visited you in Miami, I went by car to Key West. Mm-hmm. And this is, you will probably know these bridges here, where you can drive to the southest point of Florida. Yep. And I was planning a nice little project here. This is a little runway next to a road. And I just want to show you, if you want to do a corridor mapping project, you just add element. You say, I want to draw a new corridor. And then you just go from here to there, and from here to there, and you say finished at 100 meter, done. So corridor mapping completed. You can see the images. It's flying 5 runs. You can decide whether it's 5 runs or 3 runs or 2 runs. But this is all with the real overlap and with the here it's doing a 360 turn. So you can be sure that when it's turning around the road, it's making a 360 to make sure that all the images are nadir images, so vertically down and not in a bank angle. So this is a professional tool for blending corridor mapping, area mapping, all kind of LiDAR mapping, and all the parameters are pretty much automatically calculated. And all the user has to do is defining the takeoff location, landing location, which is pretty much the same, and to define the parameters for the flight in terms of overlap and altitude. And last but not least, to do some little fine tuning to make sure there are no red lines. If there are red lines, you get a warning. So never been that easy to do drone flights like with the Trinity F90 Plus system. And maybe what I forgot is once you plug in the included ADS-B transponder receiver, which is a little tiny black box you plug in with USB to your laptop, you will see all the manned aviation air traffic on your map. So while you are flying the Trinity, all the air traffic is shown on your map, and you get a nice situation awareness to avoid conflicts with the manned aviation. Well, we have seen that in Palm Bay, where we operated on this Valkyria airfield, same time while the guys have been flying their traffic circuits, and no factor at all. We knew where they are, and they knew where we are, because we also been sending our transponder location. Everybody is happy.
And the last question I really have it's been coming up quite a bit. It's going to be coming down to the beyond visual line of sight that we have here in the U.S. Can you touch on where Quantum is with the beyond visual line of sight?
This is different in all countries. So in Germany, we are already flying beyond visual line of sight. What we need to do is we have to stay with a kind of a SORA, which is like in what is it called in the US? You have to create some special cases for the FAA, where you do some risk assessment. So that's how it works in Germany. So you have to decide where you want to fly beyond the visual line of sight, and then you have to create a risk assessment, a so-called SORA, where you define what the limited what the dangerous factors are. So what can happen worst, like air to ground risk, air to air risk, and so on. And there the Trinity is on a good ranking because of the way we built the Trinity, so that it's not a massive airframe, like for example, let's say, do I know any massive one like the Wingtra? Wingtra is a massive one. This is plastic. This is pure one piece of equipment. And if this hits your propeller or whatever of a manned aviation aircraft or a windshield, it's quite fatal. Others like this Trinity, like the Sensefly, like the, let's say, the UX-11 from Del Air, these are lightweighted aircraft built out of foam, like it's not styropor, it's Elapor, but this gives the material a kind of wanted weakness. So we want that it's a weak system in terms of it's better to destroy your aircraft than to destroy an aircraft which you hit. Or even if the Trinity would hit a person on the ground, it's not a hard hit because it's a lightweighted material, and it really depends. The only hard point is the battery in the front. But even the battery in the front, which is with a soft cover, is not much harder than a real rugby or football hitting you on full speed. Like from a terms of speed, 80 meters per second is much slower than any football shot by a professional towards your face.
Right.
So a football into your face might hit you harder than the Trinity in your face. Just to remember, we are talking about speed, and speed is a mass, and the more speed you have, the more fatal is a direct hit. And therefore, the Trinity gets a very good ranking for risk assessment, as well as for as ground as air. And we get a very good ranking for the strobe lights we have. So the green, red, and white strobe light, then the signal stickers we have on the wings to make it visible from a huge distance. And of course, the active transponder solution. which we registered in India as a kind of detect and avoid system. It's not an automatic detect and avoid system, like having the drone flying and an aircraft is approaching and then it's automatically flying an avoidance maneuver. But this is already complicated in the manned aviation. So most of the maneuvers flown in the manned aviation, and I'm flying as a pilot here in Germany, is manual avoidance maneuver. The air traffic controller is telling you, oh, there's a conflict in your 3 o'clock position, same heading towards you, and you will avoid by flying a maneuver. And that's exactly what the drone pilot is doing. You as a drone pilot, you get a message, you get a visual warning that something is near you and is in the same altitude and it's approaching you. And then it's up to you as a pilot to decide whether you want to descend, you want to climb, or you want to bring it home. And the same for the manned aviation pilot. He will, if he sees your aircraft on a transponder receiver, he has to decide whether he wants to avoid to the right side and climb, or whatever he wants to do as a counteraction. But it's very difficult to work on kind of automatic detect and avoid systems, because you never know what the other guy is doing. But back to your question, beyond visual line of sight, it really depends on how politics in the US are going on, whether politics want to make use of drones easy and they want to integrate it in the airspace. And we do all that, what is needed. So we are compatible to this airspace architecture. So our autopilot and also the next autopilot we will embed, which is no user will see a difference between the 2 autopilots. We'll have the architecture to communicate with airspace network. But first of all, there are people which have to do decisions about how to integrate drones into the airspace in the US, different in Europe, different in, well, even in Europe, it's a mess. It's every single state is doing different things at the moment. And the only country I know at the moment where, or 2 countries I know actually at the moment, where these things are regulated in a very good way and we are 100% conform with everything, is India. Mm-hmm. India works terrifically. It's perfect. So they have a very good law. And we are the only UAV manufacturer who managed to register for the DGCA clearance. So our aircraft is fully licensed in the Indian airspace. And in Australia. Australia is already working with our Trinity on a beyond visual line of sight COA. Yeah.
Perfect.
US, we are pretty close to it, I would say. Yeah. Some people are already using Trinity for pilot projects, for some first projects, but we need to see how this is going on. But anyway, even visual line of sight means for the Trinity 1.2 kilometers, let's say 3/4 of a mile. 3/4 of a mile is easily doable within visual line of sight, because the Trinity is much bigger than a small copter, and therefore you can already cover a nice area. Mm-hmm. And not as big as the one you have seen in my previous proof of concept, but you can cover a nice area with the Trinity, much more than with any copter.
Absolutely. So just 2 more questions, because I think we've done a lot of Q&A. I mean, we've had about 80 questions so far. So we've done a lot of good Q&A during the presentation and just kind of ticking the boxes off as we're talking and discussing the Trinity. One more question I want to address, well, 2 more, is does the F90 have a ceiling limit? Does it have a height ceiling limit?
Yeah, the official height ceiling limit, depending on for the air pressure, you're talking about air pressure and about height density. Air density is actually 3,000 meters. That's what is published in the manual and in the spec sheet. But we know that our customers in Chile are operating in 4,600 meters. They are doing that without, out of the specs. Because we did not yet adjust our specs. but we got back all the log files and all the flight logs and everything, and we will probably soon change the envelope to more than 4,000 meters, because we have not seen any issue when operating in 4,600 meters above sea level. So this seems to be doable, and it seems to be safe. But from a manufacturer point of view right now, at the moment, if you want to keep it within the warranty, you should not operate above 3,000 meter mean sea level. But as I said, well, if my customers, and we already published this in LinkedIn too, also the details on that, they flew in Chile at 4,600 meters mean sea level.
Perfect. And then my
But
last
in Germany, it's hard to do these tests because we are running out of nice peaks. We don't have we have mountains bigger than that, not in Germany, but in Europe, in the Alps, we have mountains bigger than 4,600 meters, but these mountains are not easy accessible. So you can't use a car to get on top of them like you can do in Chile. So for us, it's a bit, we just didn't test it yet because they have not yet have the right possibility and the chance to do that here with an easy access. The highest mountain we can access with a kind of a cable cabin kind of lift is 3,800 meters in Switzerland. Mm-hmm. But everything more than that is super complicated, and you probably need a helicopter to get on top of it.
We're not going to get any readouts of Everest anytime soon.
But I think Florida is not an issue regarding the mean sea level altitude.
Right. One more question that I have, and it's actually pertaining to what you're sharing right now on your screen with Qbase, is when you're flying over multiple locations. Right here, I'm seeing that you have 3 locations that you wanted to fly over. Are those files being stored separately? So as soon as the VTOL is finished flying one area and it goes off to the next location to then start mapping again and taking its images, do they save in separate files and all?
They all save in the same image folder. Okay. But as they are geotagged, it's like geotagging your iPhone photographs. They are located anyway. So later you can use the geotag locations to separate them, or you can use the time tags. Whenever it flies from the last image of the first mission to the next one, there will be a huge gap in the timestamps. So you can easily separate the images in between the single areas. What you mean is, if you create like element takeoff and landing, we take off here, for example, and you have an area, you do one area here, and you do a second one here, right? Show area, no, right, show area, and you do a second one here. Yeah, so that's it.
Perfect.
And here now we have an example of 3 hour 50. That's a good example. It's a mission of 3 hours 53 minutes. And here you see the orange line. That's where the drone will automatically abort mission and fly home to change batteries. And then after landing, you change the battery and it will continue the mission where it stopped. So you can keep this as one mission and you just have to fly 3 batteries. Here you can see on the left side, total flight time, 3 hours, 53 minutes, 3 batteries.
Perfect. Well, Martin, this is a pleasure, man. I can say I've easily learned quite a lot, to be honest with you. And you've actually answered quite a lot of questions that I've had about the unit as well. I know we've done quite a lot of trainings and everything like that too on Qbase, which I would say that's where a majority of the time needs to be spent when you're learning about the Trinity systems, because as you continue to demonstrate, it's such an easy platform to use.
Absolutely.
Once you've got a clear understanding of all the parameters that you need to be putting into Qbase, and you really understand the location and all the feedback and data that the drone is also giving you, it's very seamless. I know that when we did our training and we did our mission planners with Qbase, for me, it took maybe like 1 or 2 times. You reviewed it with me. You helped me make those adjustments when I was seeing red and yellow lines everywhere. But, it ended up coming out really, really nice. And then we processed with Pix4D, which was phenomenal.
Yeah.
So it's a great product. It's a really good
Yeah,
product.
please, if you are coming up with more questions in the future and you want to learn a little bit more about Qbase 3D, just touch base with me. And the same for your clients. If you work with your clients and they come up with a question which is maybe a super complex question because it's something very, very special and very unique because they're operating in a very special location. They can, of course, if you at Drone Nerds are running out of ideas, they can touch base with our support team. We have a nicely growing support team at Quantum Systems, and we are happy to take the support questions and tickets. And usually my colleagues are very, very well. They like helping even end customers. So if something really difficult is to do, and they better to ask than to fly with a kind of an uncertainness. So ask the questions, and we and the Drone Nerds team, everybody will try to help to make a very safe and very, very professional mission planning together.
Yeah, and I will send out, we'll send out the recording of the webinar when this is done, and I'll include Sam's contact information. So if anyone has any questions that weren't answered or wants to reach out, you'll have Sam's contact information.
Cool. Yeah, and if there are any questions, Sam, you will receive from our guests. Please let me know if you need some help, and let me just try to summarize a bit. Last slide for today: the key features of the Trinity. Please keep in mind we are talking about a minimum 90-minute flight time for US, Australia, Europe, and so on. It's 60 minutes outside US, like if you are watching us from, let's say, Colombia, Costa Rica, Cuba, wherever you are. Don't worry, we even send unlock licenses to Colombia, Panama, Brazil, Chile, and so on. It's doable, but it will take us some time to go through the German bureaucracy. We have the various payloads, all plug and play, including the new Cube 240 survey grade and affordable LiDAR. The PPK and iBase are included in the basic package. And we get a better than 2 centimeter accuracy without any ground control points. The complete package of a Trinity is definitely below 20,000 euro, depending on configuration and cameras. And the modular design made in Germany is speaking for itself. You have a fast and safe vertical takeoff and landing. You have an optional ADS-B out to be visible for other airspace users. We have an easy 3D flight planning with automatic terrain following. I hope I've been able to show this a little bit. And we have a kind of a high wind resistance. So for takeoff and landing, it's more than 8-9 meters per second, and for the flight in a higher altitude, it's a 12 meters per second wind speed. And last not least, it's easy to use with a high level of extra safety features. And yeah, touch base with Drone Nerds, get your quote. If you are, let me mention that too. If you are somewhere in the United States or in Latin America, and you are using a Wingtra, and your Wingtra is younger than 12 months, and you still have the invoice, send the invoice to Sam and Michelle, and they will provide 2 Trinities for the price of 1 Wingtra. 3 days left for this special offer. So you will get 2 Trinities for the price you paid for 1 Wingtra. Just send the old invoice to Sam and Michelle, and get your quote, and make sure you do it within the next 3 days. End of campaign is the 18th, and then get started with a fleet of Trinities.
Sounds good. Martin, again, man, thank you so much. It's always a pleasure when we connect and go over this amazing product. I always love the insight that you bring, and to anybody else that has they're looking for very specific examples of what the Quantum can do. As we saw when Martin was going through his Rolodex of all the different things that he's mapped and done all over the world, just reach out to us, let us know, and we'll connect and we'll try to get you some case studies and some different examples as well.
Right. Thank you very much for listening and watching us today. And thanks a lot, Zem and Michelle, for hosting this Tech Talk. It was my pleasure to be with you and to spend this time with you, and hope to see you soon.
Thank you so much for being
Thank
here,
you,
Martin, and thank you everybody for attending. Have a great day.
Yeah, have a great day. Bye-bye.
Bye.